Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Okay. Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing in my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is Flex Start. Thank you.
Okay, good morning. What you saw just now was not a glimpse into the future. This is happening now, today. This is a representation of a D11 steam turbine that's currently running in Southern California. We call these representations digital twins. What you saw was an example of the human mind working with the mind of our machines. What's a digital twin? It's a living model that drives a business outcome. So this model gets data, gets operational data and environmental data, and constantly updates itself. It also can reach into the fleet, the 125 D11 turbines, and it acquires knowledge from them and learning from them, and it incorporates this into the model. And it uses this to drive business outcomes. It can drive outcomes like it can predict, or it can warn us and then predict failures to reduce maintenance cost and unplanned outages. It can give us the ability to optimize or provide mitigation events when we find out that we have these type of failures. And it can also allow us to forecast opportunities and actually benefit from these opportunities. So let me step back and actually walk you through what occurred in this digital twin in a very simplified way. So when you think about the twin, it really operates in 3 stages: see, think, and do. So in the seeing stage, and I'll relate this to what you saw previously, in the seeing stage, what it's doing, it's actually gathering data of its situation to give you a warning or a prediction. This data that comes in is both operational data and environmental data. Operational data like the steam temperatures, the bowl temperatures, the rotor speeds. It takes that data in and it uses a model, that living model. This is a hybrid model of physical and digital capabilities. So it's a combination of metal fatigue, metal creep, Bayesian learning, and other machine learning techniques. And it uses this to create a cumulative damage understanding of what's happening on that rotor. As it does that, when it hits a threshold, it can then warn us there's a problem. It then can actually predict the problem. It also uses similarity learning techniques to reach into that fleet of 125 other D11s and gather their knowledge as well. So this is a model that's constantly updating itself to reflect the precise conditions of the asset and then learning from others in the fleet. After it does that, it has the ability to give us these insights at the right time. That's the first stage. And it does that through APM and using the digital thread to get all that data. The second stage is the think stage. This is when I asked the twin to give me options that I could pursue. To do that, it ran simulations. Over 58,000 simulations, running them on the Predix platform, as Harel described in the cloud, on those edge boxes. It's looking at historical data, it's looking at fleet data, it's looking at lifing models, it's looking at forecasts for revenue and cost, and it's giving you a number of options. It then reasons across the option based upon the risk and confidence that it can deliver. And with that, it delivered us two options. One that was manual, and one that could be delivered by an application that would run on a control system on the edge, exactly as described before. Now we get to the do stage. The do stage is all about informing us and executing what needs to be done. So in option one, in the manual option, what you could do is you can have it prescribed to you. What's the load rates, the ramp rates, the steam temperature that's needed for an operator to actually manually input. And all that is logged in APM and delivered to an operator to manually input. Or you can use an app downloaded to the edge, running analytics on the edge, one of those boxes you saw previously. Now that app can run much more precisely. It can precisely monitor the load and the ramp rates, aligning it with the steam temperature so that the thermal stresses on the rotor are minimal. That's how you get to that 25% reduction number. It also, by doing that, allows you to start a lot faster and burn less fuel. That's where you see the other benefits show up. All of this executing on an edge device. That's see, think, and do. These are the digital twins working with us, with the minds of the machines, creating these capabilities. Now, what if I wanted to go in a much more immersive environment and have the twin help me understand the problem? How about I use one of these Microsoft HoloLens, which I suddenly found here. So what I'm going to do is I'm actually going to use this lens to get a much more immersive environment. So what we would normally do is we would normally go into the actual physical plant and look at the steam turbine itself, the physical steam turbine. And from that physical steam turbine, what I would do there, let's make sure we get this to go. Right. What I would do there is I would overlay all of my digital capabilities on the physical asset, seeing exactly where the damage was occurring. Now, as I can't do that, I can't take us all on that journey, it's 6 hours away. What I'll do is I'll ask the twin to bring that to us, take the exact CAD dimensions of the asset from manufacturing and maintenance, and simulate it in this environment. All right? Now, as it begins to do that, right, you'll see the steam turbine appear. And it should be appearing any second now. Or is it one of these usual glitches when you do these things that you see appearing? All right, might be a glitch. There it is, in the audience. Now I can have the twin help me. Twin, open the steam turbine. Okay, that didn't work. Twin, open the steam turbine. Let's see if that works better. All right, let's use the hand gesture. Okay, give it a second here. Okay. Twin, show me where the where is. Twin, show me the length of the where and plot a baseline for me so I can see if we did no mitigation, what that would be. Okay, twin, close the steam turbine. Now this thing is still floating around. What you saw there was an experience with one of 551,000 digital twins that we have currently running. This one can communicate with us in a richness of voice and vision that is usually unbelievable, but quite real. But all of them deliver value. Several of them deliver value in different ways. So what you've seen here is a list of the other twins that we have. So we have parts twins, which is what you just saw, the rotor failure prediction. And this parts twins, what that can do, just like we saw, is deliver an early warning about a problem, as well as tell you about the actual failure that you'll encounter. We have product twins. What product twins do is they actually optimize the remaining life of a steam turbine or any asset, and they do it against maintenance cost. What process twins do is they find ways to optimize scheduling of field engineers, in this example, to maximize the utilization. What the system twins do is the system twins find a way to actually optimize against a multiplicity of KPIs, balancing things like revenue against remaining life, against maintenance cost. All of these twins providing value. So when you think about the era that we're going into of emergence, this is the era in which we have the minds of the humans, maybe 6 billion of them, talking to the minds of the machines, 50 billion of them. That convergence is going to profoundly change everything we know. We believe with the power that we have in Predix, the Thread, the Twin, and APM, we are perfectly suited with our partners and our customers to move to the next space. Thank you very much for your time, and my thanks to the Twin.